Thank you. Dr. Wilson's talk gave a very good introduction to my study because excuse me. I use gnotobiotic pig as model to study human vaccines. So in this study, I'm going to talk about this okay. Yeah, okay. So to study the immune correlates of rotavirus vaccine-induced protective immunity using this very unique B-cell deficient neonatal gnotobiotic pigs. Okay. So even though there are 2 licensed rotavirus vaccines on the market, we are still not fully understand what's the determinants of protective immunity induced by rotavirus vaccines. Our previous studies and others have demonstrated a significant correlation between virus-specific intestinal IgA antibody, secreting cell responses, and serum IgA titers and protective immunity against rotavirus shedding and diarrhea. Studies also correlated interferon-gamma producing CD4 and CD8 T cell response with protection against rotavirus diarrhea in gnotobiotic pigs in my early studies, and also in influenza virus disease. There is a very recent study published in Nature Medicine. It showed that in the absence of cross-reactive neutralizing antibodies, interferon-gamma producing CD8 T cells specific to conserved viral epitopes correlated with cross-protection against symptomatic influenza. So the objectives of this study was to differentiate the role of cellular from humoral immune responses in the protection against rotavirus infection and diarrhea, and to dissect the contributions of CD4 and CD8 T cells, B cells, and innate lymphocytes to the vaccine-induced protection against rotavirus diarrhea using a B cell deficient HCKO neonatal gnotobiotic pigs and CD8 T cell depleted HCKO pigs. So what are those HCKO pigs? Those pigs are generated by a company called Revivocor. Those pigs have the gene encoding for the immunoglobulin heavy chain knocked out. This knockout causes the impairment of the VDJ rearrangements. They are devoid of germinal center development. Those pigs, like any immature or immunoglobulin secreting cells, they are totally incapable of producing any antibodies. However, they have an intact innate and T cell immune system. We did an autogenous study of lymphocytes in those pigs. Here I will just show 2 examples of the data. We examined the immature B cells with flow cytometry, used 5 different surface markers in 7 different lymphoid tissues. We did not detect any immature B cells in the HCKO pigs, but you can see the normal frequency of those immature B cells in the wild type animal. Here shows the total immunoglobulin secreting cells detected in wild type pigs, but we don't detect anything in those HCKO pigs. So we use this pig for the vaccine study. We have these 4 treatment groups. The human rotavirus, attenuated human rotavirus vaccinated wild-type pigs, vaccinated HCKO pigs. HCKO pigs depleted of CD8 cells and HCKO controls, and also we have the wild-type controls. I did not include that group because this control is more appropriate here. A subset of those HCKO pigs were intravenously injected with anti-pig CD8 alpha antibody at 28 days of age. The efficiency of CD8 cell depletion in blood were monitored using flow cytometry at 31 days, 33 days, and 40 days of age. And then all pigs were colonized with a single lactobacillus ruminant GG just as an immunostimulator to help them develop the immune response. In the vaccinated group, pigs received 2 doses of oral attenuated rotavirus vaccine, 1 dose at 5 days of age, another one is 15 days of age. A subset of pigs were challenged with virulent human rotavirus at 28 days after the first dose of rotavirus vaccine. And the protection post-challenge was assessed by reduction of diarrhea and virus shedding from post-challenge day 0 to 7. Virus shedding quantity were measured by both ELISA for the amount of antigen and for infectious particle by CCIF. Okay. So this just shows the timeline of all the treatment. The antibody injection occurred at 23 days of age, not 23 days PID, which is 28 days of age, and then we monitor 3 times variant challenge at 28 PID, which is 33 days of age. After challenge, we swabbed the pigs daily, measured virus shedding and diarrhea, and the pigs were euthanized either at PID 28 or PCD 7. We collect lymphoid tissues from elim, intraepithelial lymphocytes, spleen, and blood upon euthanasia, and the mononuclear cells were stimulated in vitro with rotavirus antigen. And to measure the intracellular interferon gamma producing CD4 and CD8 T cells, gamma delta T cells, NK cells by flow cytometry. Okay. This slide shows the efficiency of CD8 cell depletion. This is monitored at 31 days. This is 3 days post the antibody injection. We see a 0.32% of CD8 positive cells. At PPD 33, the frequency reduced to 0.78%, and this is a non-injected pig group. You see the CD8 positive cells was 32%, so there is a dramatic reduction, which is about 97%. And when at 40 days of age, which is 12 days after injection, the CD8 positive cells start recovering a little bit. Frequency increased to 2.3%, which is still dramatically lower than the non-injected pigs. So this indicates that a single dose of CD8 antibody injection is sufficient to deplete almost all the CD8 positive cells during this time period. This slide shows the protection data after challenge. Here we have the clinical signs and virus shedding. Percentage of diarrhea, percentage of virus shedding, the mean days to onset of diarrhea, onset of shedding, and the mean duration of days of diarrhea, of shedding, and the mean accumulative fecal score and the peak titers of the virus shed. When we compare the knockout, the HCKO knockout pig to the wild type, we see that the mean days to onset of virus shedding and the mean days of virus diarrhea was significantly changed. That is significant early onset of virus shedding and a significant longer mean duration of virus shedding. When we compare the CD8 depleted cells, the pigs to the wild type, we see here a longer mean duration of diarrhea and increased mean cumulative diarrhea score. And also higher peak titer. However, those numbers were not statistically significant. I think the main reason is because we only have very small a number in each group because those peaks are very difficult to make. Interestingly, we saw that compared to the non-vaccinated control pigs, those both deficient and CD8 depleted pigs still had a significantly lower mean peak titer. What this means is that even the pigs do not have antibody, do not have CD8 T cells, probably the CD4 T cells play an important role in control the virus replication, so reduce the virus titer. Okay. So then we measured the amount of antigen shed with ELISA among these 4 groups. What we see that the vaccinated wild type and the HCKO knockout pigs shed a similar quantity of the virus over these 7 days post-challenge, and both groups finished shedding at PCD 7. The non-vaccinated HCKO control pigs shed a much higher titer of the virus, this diamond line, but they also finished shedding at 7 days. In contrast, the CD8 cell depleted vaccinated HCKO pigs shed higher titers or significantly higher titer amount of virus from PCD2 to PCD7 compared to the wild type and the non-CD8 depleted pigs. The virus shedding continued beyond PCD7. So then we calculated the area under the curve of virus shedding measured by CCIF. This takes consideration of the both length of shedding and the amount of infectious particles shed every day. We see a similar result compared to the ELISA. Here, the wild type and the HCKO pigs had lower AUC compared to the CD8 depleted vaccinated pigs and the non-vaccinated control pigs. So here we look at the effect of this B-cell depletion and CD8 depletion on the immune response. Here, this slide shows that the CD4 and CD8 T cell among lymphocytes. What we found is that those HCKO pigs had increased or significantly increased the frequency of CD4 and CD8 T cells in all the tissues pre and post-challenge compared to the wild type pigs. This is compare. You see this hatched bar group compared to the white bar. It's across all the tissues. And then the CD8 T cell depletion decreased the frequency of CD8 T cells as expected, but it also increased or significantly increased the CD4 T cells in spleen and blood pre and post challenge. Is here you compare the solid bar to the hatched bar, and also they increased the CD4 T cells in ileum and IEL post challenge is here. Then we look at this interferon gamma producing CD4 and CD8 T cells. We found that HCKO pigs had increased or significantly increased interferon gamma producing CD4 and CD8 T cells in all tissues here compared to the wild type pre and post challenge. And this CD8 T cell depletion reduced the frequency of interferon gamma producing CD8 T cells in all tissues as expected. It also reduced CD4 T cells in spleen and blood pre-challenge, as shown here, and in spleen post-challenge. But it significantly increased interferon gamma producing CD4 T cells in ileum post-challenge, as shown here. And we also looked at the innate immune cells, including the NK cells and the interferon gamma producing NK cells. HCKO pigs had a similar frequency of NK cells compared to the wild type pigs. And the CD8 cell depletion reduced or significantly reduced NK cells in spleen and blood pre and post challenge because NK cells also express CD8 marker. Both the HCKO pigs and the CD8 cell depleted pigs had a significantly higher frequency of interferon gamma producing NK cells in all tissues post-challenge compared to wild-type pigs. This is because the increased virus replication, the stronger stimulation of NK cell response post-challenge. And this slide shows the interferon gamma producing CD8 negative and CD8 positive gamma delta T cell response. Those are another subset of innate lymphocytes. Those HCKO pigs had similar frequency of total gamma delta T cells compared to the wild type CD8 T cell depleted pigs. We did not show the data here. CD8 depletion significantly reduced those CD8 positive gamma delta T cell frequency in IL spleen pre and post challenge, and it's because they carry CD8 marker, of course. But CD8 cell depleted HCKO pigs had a significantly higher frequency of interferon gamma producing CD8 negative gamma delta T cell response in ileum and blood compared to the non-depleted pigs post-challenge. So this is a compensatory increase of innate immune cells post-challenge. So to summarize the impact of this B-cell deficiency and CD8 depletion on the protection, those HCKO pigs significantly speed up the onset and of virus shedding and prolonged the virus shedding compared to the wild-type pigs. therefore imply that B cell response delays the onset and shorten the duration of virus shedding. CD cell depletion in those HCKO peaks increase the quantity of virus shedding compared to the HCKO peaks and the prolonged duration of diarrhea compared to the wild type peaks. So that implies CD T cells response reduce magnitude of virus replication and the length of diarrhea. Those HCKO and CD8 depleted peaks still show lower mean peak titer compared to non-vaccinated control peaks. Therefore, the CD8 T cell response probably reduced the magnitude of virus replication. And then the impact on the immune response, the HCKO peaks increase CD4 and CD8 T cell population, increase interferon-gamma producing CD4 and CD8 T cells and NK cells in a compensatory manner. CD8 cell depletion further increased CD4 T cell population, but reduced both interferon-gamma producing CD8 and CD4 T cell, a challenge leading to delayed clearance of virus infection. This depletion, CD8 depletion, caused the prolonged infection, which in turn increased interferon-gamma producing T cell response, including CD4 T cells in ileum, CD8 negative gamma delta T cells in ileum and blood, and NK cells in all tissues post-challenge. So this take-home message. So B cells' role is to delay virus shedding and diarrhea onset and shorten virus shedding. The contribution of CD4 T cells in protecting immunity is shorten the duration period and decrease shedding quantity. CD4 T cells help to resolve the infection of rotavirus. Those B cell deficient had increased CD4 and CD8 T cell population as a compensatory mechanism, but they have increased interferon-gamma producing CD4 and CD8 T cells and NK cells. So the innate immune system in those HCKO peaks is intact. However, increased innate immune response in the B cell deficient and CD8 depleted peaks are not sufficient to compensate for the lack of adaptive immune response in protection against rotavirus challenge. The critical role of T cell in rotavirus vaccine-induced protective immunity was confirmed in this study. Both CD4 and CD8 T cells directly contribute to vaccine-induced protective immunity. Therefore, to enhance the vaccine efficacy, we need to stimulate both humoral and cellular immunity. I would like to acknowledge my funding agency, the NIH R1 grant, and the people who helped with the veterinary and animal care, and the review people, they generate those HCKO peaks used in this study. Thank you. Thank you so much.
Any questions?
Very nice study. How do you explain the role of B cells in the very early protection against rotavirus, or in the delay of onset? Because that is, I think, surprising.
In the wild type yes. Animal, yeah, it has B cell, and you see the time of challenge is PID 28, which the vaccine started at 5 days of age. That time we will see very nice antibody secreting cells and antibodies against rotavirus. That's how the B cell provided protection.
Thank you.